All right, question number 10. A stone is thrown vertically into the air at initial velocity of 47 feet per second on a different planet. The heights s in feet of the stone above the ground, t seconds, is s equals 87 minus 3t squared, and on Earth it is s equals 87t minus 16t squared. How much higher will the stone travel on the other planet than the Earth? Since both of these questions are in terms of s, it'll be hard to differentiate. So I'm going to change the variable to p for planet and e for Earth, just to kind of start out. And we're looking for how much higher will it go. So we want to find the maximum. We will need to find the derivative and set that equal to 0 to get the when the velocity is 0, we'll get the maximum height. All right, so I'm going to say p for the other planet equation, and I'm going to say that is equal to 87t minus 3t squared. And then the Earth equation, I'm going to say E for Earth, and that was 87t minus 16t squared. All right, and it looks like we have two parts we want to kind of fill in. It says when an object is thrown upward, it reaches the highest point. And this is just before it starts to fall back to the ground. Its blank will be 0. So when it reaches its highest point, its velocity will be 0. It's going up, velocity slows down, starts coming back down. Now it says, therefore, to find the maximum heights of the two objects, use the blank equation blank. The velocity equation v ds dt. So I guess velocity equation. All right, the stone will travel blank higher than on the other planet. Okay, so we're going to find the derivative. So I'm going to say it's going to be 87 minus 6t. I'll set this equal to 0. So when velocity is equal to 0, so move the term over, so we'll get 6t equals 87, and then we'll divide by 6. So at time, what time we will find when we make that maximum? Let's see, 87 divided by 6. Okay, so on the other planet, it reaches its maximum at 14.5 seconds. So I'm going to take this 14.5 seconds, plug it in, and that'll give me the maximum height on the other planet. Same thing here. I'm going to find the derivative. So I'm going to say E prime. It's going to give me 87 minus 32t. Set this equal to 0. So we'll get 32t equals 87, and then we'll divide by 32. And so we'll get 87 divided by 32. And that'll give us the time it reaches its maximum height on the Earth. So it reaches its maximum height on the Earth after about 2.72. All right. I'm going to plug these values in. We'll just let the calculator do that lifting. So I'm going to do 87 times 14.5. And then minus the 3 times 14.5. That'll be squared. All right, so we are getting a maximum height of 630.75 feet on the other planet. We're going to do the same thing for the Earth. We're going to plug in the 2.72 approximately. That rounding might throw it off. I wonder if we should use that exact value. Just say 87 over, yeah, I'll do the exact value. I'll just put in 87 over 32 as my time instead of dividing it. So at this point right here, I'm going to do T equals 87 divided by 32. The reason is the more you round, the more it throws off the answer. So if I put in a rounded answer and then I round it again at the end, I'll be a little bit off. So we're going to do 87 times 87 divided by the 32. So that's the 87t, and then minus 16, and then we'll do 87 divided by the 32, and this quantity will be squared. All right, so this will give me the exact height on Earth. So on Earth, because we get a decimal again, its height is 118.27. All right, so then we can subtract these 15. That'll give us 8. 6 from 2 is 4. That'll give us 9 is 1, 1, 5. Okay, so 5, 11, 48 is the difference in the height. It's going to go that much higher on the other planet. So the stone travels blank feet higher on the other planet. Do not round to the final answer, round to the nearest whole number as needed. Okay, so 511, I guess. 511 feet higher on the other planet.